Hi, in this video we see another example of a dynamic programming problem, the subset sum problem. The input to the subset sum problem are n integer weights, w1, w2, ... wn, and a target t. And what you want as output is the number of subsets of the weights that sum to t. The way in which I can write this is as follows. I can consider every string x of length n, made just of bits, as a subset of the elements from 1 to n. Okay? And then what I'm looking for is the number of x's, such that if you sum for I that goes from 1 to n wi times xi, you will get t. Okay, in this sum, when xi is 0, you don't get the weight wi. When xi is 1, you get it. So the subset corresponds to the bits of x, which are 1. As an example, when n is equal to 3 and the target is 12, and the weights are 2, 3, 5, 7, and 10, your output is 3, because there are 3 ways to write 12 as 10 plus 2, 7 plus 5, and 7 plus 3 plus 2. Let us see how we arrive at subproblems and recursion. If you want to get to a sum of t, you can either use the weight wn, in which case you will need to get to sum t minus wn, just using the weights w1 to wn minus 1, or else you're not even using wn, and then you need to get to exactly t using the weights w1 to wn minus 1. In other words, either you get to t using the other weights, or else you must get to t minus wn using the other weights. Okay, this leads us to formulate the following subproblems. As subproblems, I'm going to have SIS, which is the number of subsets just of the first I weights, the number of strings x of length I, whose sum is equal to S. Okay? This sum here is written as the sum for j that goes from 1 to I of wj dot xj. Okay, so it's a subset just of the first I weights, and I'm using j to index the weights. And reasoning as before, we obtain the following recursion, that SIS is equal to S of I minus 1 S. That's the case in which you're not even using the weight wi, or plus S I minus 1 comma S minus wi. This is the case in which you are using the weight wi, and then you need to get to S minus wi using the first I minus 1 weights. Okay, how many subproblems are there? So the number of subproblems really depends on how big a target you're shooting for. Okay, and for an arbitrary t, the number of subproblems will be t times n. Okay, so you have t choices for this s here and n choices for this I here. We never need to consider sums which are larger than t, because I'm assuming that all my weights are positive. Okay, so we're making the assumption that the weights are positive. The weights can be negative. You have to modify the code accordingly. Okay, given this, we can arrive at a fairly straightforward dynamic programming algorithm. Okay, again, here is my input, integers w1, w2, all the way to wn, and a target t. And again, I'm assuming that the weights are positive. You want to output the number of subsets which give you t. Okay, and I'm going to keep around a matrix. Okay. So the number of columns will be n. Okay, this corresponds to which weights you are using. And the number of rows will be the possible sums. Okay. The algorithm proceeds by filling one column at a time. So first you fill the first column. Okay, the first column corresponds to the first weight. So you cannot use the weight W1, in which case you get to sum of 0. So there is one way to get to sum of 0. Or you can use the weight W1, in which case you get to sum W1. So you just put the 1 in these two positions. And then for every other column, you just fill it using the recursion. Okay, so for I goes from 2 to n. You go through every possible sum and use the recursion to fill it. What does the recursion say? It says that the entry is in this table can be obtained as a sum of I-1 s or I-1 s minus wi. So some value here depending on what's the wi. That's the entire code. The running time would be order of t times n, because this for loop has n iterations and this for loop has t iterations. And we can also ask about space in dynamic programming. The trivial space bound that you have here is stored in the entire matrix, but you can do something better. Okay, you can realize that actually to fill a column, I just need to know the previous column. Okay, so you only have to keep around 2 columns, and that gives a better space bound of order of t. Okay, let us now see an example. So we have 3 weights and target of 12. The weights are 2, 3, 5, 7, 10. Okay, and I'm going to think of them in this order. So the first weight is 2, the second 3, and so on. And the output, as we saw earlier, is 3. Okay, there are 3 subsets that sum to 12. 10 plus 2, 7 plus 5, and 7 plus 3 plus 2. So here is how the algorithm proceeds. So here you have a matrix with 5 columns, okay, corresponding to these 5 weights here, and then you have 12 rows corresponding to your target of 12. Okay, so first you fill the first column, so you put a 1 for a sum of 0, because you can always get to 0 by using no weight. And you can also get to 2 because the first weight is 2. That's why you put a 1. Okay. Then you fill the second column. So how do you go about it? Right. The second weight is 3. So you can obtain any value, okay, by summing the value for the same sum with 1 less weight, okay, plus the previous sum minus the weight. So this one here is obtained as the sum of this value here and this value here. 0 plus 1 give you 1. If I don't write an entry in the matrix, it's a 0. This 0 here is obtained as 0 plus 0. And this one here is obtained as 1 plus, as 0 plus 1. Okay. You fill this in this entire column, and then you go to the next weight. So the next weight, the third weight, is 5. Okay. So the first time this thing changes is for this value here. This 2 here is obtained as the sum of this one here and this sum here. This corresponds to writing 5 as just 5 or 2 plus 3. Okay. So this one here was for the 2 plus 3, and now I'm adding one more combination, which is just using 5. Okay. This one here is obtained as a sum of this 0 plus this one here. This one here is obtained as the sum of 0 plus this one here. This 0 here is obtained as 0 plus 0. This one here is obtained as 0 plus 5. Okay. The next weight is 7. Okay, so the first time that things changes for this location here. This is obtained as 1 plus 1. You have 2 here. This one here is 1 plus 0. This one here is 0 plus 1. This 2 here is 1 plus 3. The 0 is 0 plus 0. And this 2 here is 0 plus 5. And finally, we get to the last weight, which is 10. And so here things start changing here. This 3 here is obtained as a 2 plus 1. Okay, there are 3 ways to get to 10. The 0 here is 0 plus 0. And finally, this 3, which is what I want, is obtained as this 2. This corresponds to the subset that give me 12 without using weight 10, plus these 2 here. Okay, and this corresponds to the subset that gives me 12 using weight 10, which will be the subset here, 10 plus 2. This concludes the example, and I will see you next time.